plus 2, which is irreducibly quadratic. This will not factor, but it's squared, so it's repeated. And so when we do our partial fraction decomposition, 8x to the third plus 13x all over the x squared plus 2 squared, we're going to say then, since it's quadratic, we have to do the ax plus b all over x squared plus 2 to the first power, and then we have to do plus cx, if this is going to write, there we go. All right, cx plus d all over the x squared plus 2 raised to the second power. Now we're going to multiply by our least common denominator, x squared plus 2 raised to the second, to here, here, and there. The x squared plus 2 to the second and x squared plus 2 to the second here will reduce. We'll be left with 8x cubed plus 13x equals, when we distribute here, we'll have the ax plus b times x squared plus 2 to the first because 1 reduced. And then over here we'll have plus cx plus d, and then the x squared plus 2 and the x squared plus 2 squareds, they reduce. Now I'm trying to figure out some convenient values for x, and I'm not really seeing any. And so what we're going to have to do here is do some algebraic manipulation. You know, you could let x equal 0, but then you're going to have b times 2 plus d, and that's not really helping. If we choose a convenient value for x, you should be able to reduce it down to one unknown, and that's not really happening for us right now. So some algebraic manipulation. We'll go ahead and we'll expand this. We got our 8x cubed plus 13x equals ax cubed plus 2 times ax plus bx squared plus 2b, and then we have our plus cx plus d. Now remember, you want to group your like terms. So we have our 8x cubed plus 13x equals, well, there's no other x cubed up there, so ax cubed. I see a quadratic term there, plus b x squared. I see linear and linear, so plus, in parentheses, 2a plus c times x. I factored the x out of those two expressions there. And then I have this constant, 2b plus d. Now looking at this, I see that ax cubed must be the same thing as 8x cubed, so that tells me automatically that a must be 8. And that's going to help out a lot. I see bx squared equals, and there is no x squared over here. So what that tells me is that b is 0. Over here we have 2a plus c times x, must be 13x, but I also know that a is 8. And so we can have 13 from here is equal to 2 times 8 plus c. And so 13 is equal to 16 plus c. Therefore, c is negative 3. And then finally, 2b plus d, the constant is 0 over here. We know b is 0, so therefore d must be 0 as well. And so coming back up to your partial fraction decomposition, a is 8, b is 0, c is negative 3, and d is 0. And so we're going to be taking the integral of 8x over x squared plus 2 plus negative 3x over x squared plus 2 squared. And we'll go ahead and go to the next page and write that down. Let's see if I can copy it. Nope. Okay, we'll try that. Copy. Apparently not. All right, so we'll just write it on the next page, 8x over x squared plus 2. And then we're going to have the minus 3x over x squared plus 2 squared. dx. Okay, so we'll go ahead. I'm going to take out my 8 here. Integral of x over x squared plus 2 dx. Take out the minus 3 x over x squared plus 2 squared dx. For this integral, we're going to let u equal x squared, getting a little ahead of myself, x squared plus 2. Therefore, du is 2x dx. Now, we don't exactly have that, and so we'll write a 2 here and divide that number by 2, and then we're happy. Over here, I've already used u. I don't want to use u again, so we'll do z is equal to x squared plus 2. dz then is 2x dx. We don't have that again. We just have x dx, so we'll put a 2 and divide this number by 2. And so what we're left with is 8 over 2, 4, times the integral of 1 over u du minus 3 halves the integral of 1 over u squared. So that's going to be u to the negative second du. Integrating now, we have 4 times the natural log of the absolute value of u. Add 1 and divide, it'll become positive 3 halves times 1 over u plus c. And now it's time to, or excuse me, these should be z's here. Too many u substitutions in my day. There we go. And so now we're ready to resubstitute our u's and our z's. 4 times the natural log of the absolute value of x squared plus 2. Now, because it's x squared plus 2, that's always positive. You don't technically need the absolute value anymore. And then we're going to have plus 3 over 2 times x squared plus 2. And then we have plus c.